Hello everyone, I'm Xiaogan. In this chapter, we will talk about country flow. Why talk about country flow? Actually, we have already covered it once before. We still need to go over it again here, because this thing is too important. We can see here. Let's search directly. Wait a moment. Search for multi-threading. Here, we have already covered this once, but we still need to go over it again. If you have already learned it, then you can actually skip it. If you have already seen the content behind this, you don't need to watch it anymore. If you haven't seen it, I suggest you follow me step by step to write it or practice it, because this control flow is really very important, because it will solve during our development process handling of a large number of asynchronous situations. Of course, you can write it all synchronously, but writing it synchronously has the advantage that it's very easy to understand. That is, I send an HTTP request and I immediately get a result. That's what I mean. I need to receive this result. Before continuing down the main line, just put everything into the main line. This is completely acceptable. But sometimes we really need this asynchronous process to complete our entire framework. For example, when I start the game, there are also some things that need to remotely access network information. Locally, there are also read-write operations. Things that need to be decompressed. In this case, using counterflow is very convenient. Its advantage is not about reducing points. The point is that you can, like we wrote a task earlier, complete a parent-child relationship. And what's simpler is that it can achieve an effect of assembly and recombination. So before talking about this country flow, let me draw another diagram for you, because I might have drawn it for you back then. But I haven't drawn it yet now. So let's first talk about what we initially, if we only know blueprint. What should we know if we only know blueprint? Obviously, it's obviously like this. I can see that. If we only know blueprint, so this is our, for example, we are at the first frame. Una seri, right? Jak, hu, jak, right? Then in the case of the first frame, then in the first frame, we need to execute A, B. See, this task, assume each of the tasks A, B, C. The first takes 1 second. The second takes 2 seconds. The third takes 3 seconds. Obviously, your main thread here. Then, obviously, you are stuck. You will be stuck for 6 seconds. This is unacceptable, because these 6 seconds mean that your UI is not rendering. That is, all your keyboard and mouse on the screen will be completely unresponsive for 6 seconds. This is unacceptable. But developing this way is very convenient. Because if you only have 0.1 seconds, or operations like 0.01 seconds, then this is completely fine. Now, if this operation is more troublesome, then we will think about how to do it. Then we should do it like this. Now let's erase it. So it's still our ABC task, right? Still the ABC task. We will do it like this, because among these ABCs, there is no dependency relationship. So we will, at this point, go on an asynchronous thread. For example, we use async, Y-I-N-C, in this way. Then we use any thread. Any thread. This is our main thread. It's our main thread, right? Then this place initiates an asynchronous task of A, and it executes. It executes. It executes. It executes. And it executes for, say, 1 second, right? Then after it finishes executing, then it also executes B on this async task, and then executes C, right? This is why we need multithreading. After you learn this is the knowledge you need to master. Then it's because it takes 6 seconds. 6 seconds. Actually, 1 second is 60 frames. So actually, this should be 360 frames now. To this position, C has finished executing. At this point, he calls our main thread. And he calls the main thread. Game's way, we pass his information to the main thread. Then the main thread can continue. For example, executing low-level work. So after you finish the previous chapter, you will be able to write this code. There will be absolutely no problem, right? And with this kind of code, you can even set a 10% progress here and 40% progress here. This part is 100% completed, right? You can also keep calling it in the middle, right? You can think of it as, here you can write a dedicated function or a method called update. We sometimes like to type it out. That's what it means. Up to the progress here. This part is completely fine. What kind of problem does this cause? That is, this ABC. I wrote it all in this place. Suppose we now have a process called IEC. So what should we do? So do you have to rewrite this whole mess? That would be really painful. So our country flow. Actually, it can abstract AEC into 3 tasks. These 3 tasks, they have a fixed interface format. You just need to define the interface format and the communication data conventions. Then this thing E can be completely abstracted into F. C can be written as B. That would be perfectly fine too, because some of our tasks might just need to. They might. I mean, executing in this sequential order works very well, right? So there should be no problem here. Then actually, in our development on the 11, when it calls back here, it will be very troublesome. That is, there are many such delegates here. That is, here you only call back to your C++ main thread. You also call back to blueprint, so this place is very troublesome. That is, if we can abstract all of this into such modules, we only expose 2 delegates externally. One delegate as the success result, this result delegate, and another is our progress, a progress delegate. Then inside, however we want to initialize, we can initialize. So today the boss wants to add you. To access, add an initialization information for a coupon. Then tomorrow, the boss wants you to add a statistic for the initial health information of monsters in the level. Then at the end, go and count this. So doing it this way is perfectly fine. And the progress bar you just refreshed here is also very convenient. Okay, then we will end this lesson here. I believe everyone should have no questions. Then let's erase all of this. I'll erase all of this here. We have explained it to him, and during its actual execution process, he actually executed it like this. Let me show you. Let's go back to our main thread. Let me erase it like this for you. Go back here. Let's go to our main thread. M18-001. Have you ever thought you might write a separate thread? For example, there is a sweet bee here. There is a sweet bee, and it manages these. Let's not call it sweet bee. Let me see what we call it. What would be a suitable name for this? We erased it all like this. It's nothing. Stay the same. Here, 1, 1, 2, 3, 4. You would think, if that's the case, you would think of such a problem. You make a separate county town here. This county town specifically interacts with the main county town, our gamesways, right? This gamesway, we call it the small gamesway. And this county town does not do quests. It only communicates and interacts with the main county town. The main county town sends something over to it. It receives it, then it finishes it. He will apply for resources here. He might have a county holding this kind of resource for a one-step execution mode. Just like the ABCDEF we mentioned. Then, according to our needs, based on an enumeration, let's say it's currently initialization mode ABC. It might now be initialization mode def, and then it's already initialized. After initiation is complete, he then accepts the results of these task executions and returns them to the main thread. Right? This is completely fine, but in actual use, we wouldn't use it this way. In fact, we would eliminate the middle thread. In this thread, we directly killed it. Why did we kill it? The reason for killing it is also very simple. It's because UE5 encapsulates for you a lot of HTTP networking and I/O stuff. This stuff must be placed on the main thread to receive data, but you don't need to worry. But rest assured, when it actually communicates, it's still on other threads. That is, its result is still on the main thread. If we don't kill this thread, it's equivalent to our main thread. If it receives HTTP stuff, we would still have to manually push it to this thread dedicated to processing it. So this is really annoying. Then we just kill the middle thread directly. This is the biggest reason we use country flows. The biggest convenience. We initiate this. The ABC management task part manages these tasks. We move A, B, C, D, F to the main thread. So if we write out this architecture in the end, it actually looks like this. The front is still 1,200,304. There's no problem with this. Actually, at point A, I have a class or a list. Then at this point, we declare it as ABCD here. So at this point, it executes A. Then I won't bother with this A. Just execute it. After it finishes executing, it returns back to our ABCD location. And then at this point, it goes to execute B. Right. Execute the task of B. This is the specific task. This task will request how much memory resources, at least CPU and GPU resources. We don't care about that. Then after it finishes executing, it returns to our, we manage this country full as a whole. This ABCD area, it jumps to the C area again. So this is very convenient. Right, very convenient. So this thing, why is it important? Let me tell you. Because this framework has already been written and it's very easy to use. It's good. For this lesson, let's stop here for now. Thank you everyone.